You're listening to the Mechanic.com.au podcast, Australia's #1 podcast for automotive service and repair professionals. This week's podcast is proudly brought to you by NTK, Oxygen Sensors, the sensor specialist. I'm your host, Jason O, and today we're joined by James Filshie, who is the Senior Product Manager for NTK.
Thank you for having me.
I know it's a bit like that in the morning sometimes, isn't it, mate? Well, tell us a little bit about who you are. What's your role there at NGK? What does the Senior Product Manager do?
I lead the product management team, and so our key responsibilities are to determine what products we're going to bring in and distribute in Australia, and basically go through all the processes to get these ready for sale, which includes like setting pricing, packaging, the cataloguing, and training the sales team with all the technical know-how.
Are you a car guy? Are you a car guy yourself?
I am. I've got a couple of hobby cars.
Oh, come on. Don't tease us. What have you got?
I've got a 66 Mustang and a 67 Camaro.
Oh, now you're talking my language. Now you're talking, no school like the old school, mate. And, you know,
That's right.
A company like NGK, you've got to be able to service all ends of the market, new, old, off-road, everything else in between, don't you?
Yeah, that's right. I mean, the aftermarket's got everything out there.
Yeah, it certainly has. Well, listen, to all our listeners, welcome to the show wherever you may be listening. Today's topic is oxygen sensors. Let's get into it. James, explain the role of the pre-cat and the post-cat sensors.
All right, so the pre-cat and post-cat refers to the position of the oxygen sensor in relation to the catalytic converter. So the pre-cat sensor is positioned before the cat and is commonly referred to as the control sensor, which monitors the oxygen levels exiting the engine.
Right.
This information is then fed back into the ECU, which interprets the readings and adjusts the fuel chamber figures.
Look, quite often or not, you know, when you're in a servicing capacity, you have issues, and they will be directly related to those sensors, won't they?
Yeah. It's definitely an area that people look at first when they've got issues with the car or check engine light coming on.
And when we're talking about servicing, obviously there's a wide gamut of vehicles here in Australia that the techs are listening to this are looking after. You know, how many different types of oxygen sensors do you guys carry?
I mean, we've got around just over 1,000 part numbers.
Wow, 1,000, yeah?
And there's 3 basic types within our range.
Okay.
We've got the titania, zirconia, and the air fuel ratio sensors.
Rightio. And obviously, you know, you have some that are interchangeable. Is that right, with other makes and models?
So our part numbers are interchangeable with other brands, but in terms of part number to part number within our range, they're not interchangeable. Like, each one is very unique and specifically designed for the application that we've recommended it for.
And just out of curiosity, what's the I mean, look, this is a bit of a wide question, but what's the service life on an oxygen sensor?
They're not considered a service item. They're an item that is replaced once they've failed, basically.
Yep.
So there's no set service life for them as such, but we do recommend that you check the operation of them every major service, every 40,000 Ks or so. But I would have said, approximately from around 80,000 plus, you might, expect sensors to start, deteriorating, because as they're exposed to contaminants in the exhaust gases, they slowly degrade.
They're a critical component to running the car from an ECU point of view. It's from a diagnostic and from an input point of view. It's very important, and they can, as you said, get contaminants. Can you give us an example of some of the contaminants you've seen stuck in these things?
I mean, the most common thing is like silicon poisoning.
Yes,
which is something that can deposit on the sensor element itself, which sort of affects the operation. It stops the ion transfer through the sensing element, and so distorts the output. And other contaminants is just whatever additives are in the fuels. We don't know exactly what's in there, and some of them can adhere to the sensors and affect their output. So
there's a wide variety out there, isn't it? It's a bit potluck sometimes at a service station. Well, let's talk about the loop terms, open and closed loop. Can you give us a quick run through as to what they mean?
All right. So an oxygen sensor has to reach a minimum operating temperature before it becomes operational, and that's around 350 degrees Celsius.
Yeah, right.
And so when the car is first started from cold, there's a period of time where the O2 sensor is heating up, and so therefore isn't communicating with the ECU. And so this period of time we refer to as the open loop mode. And when the vehicle's in open loop mode, the ECUs are generally programmed to run slightly on the rich side. And then once the sensor reaches this minimum temperature of 350 degrees, it begins to then communicate with the ECU, and this is what we call closed loop mode.
Clean
so
things
then
up a bit.
The whole system's closed, and there's feedback and adjusting the fuel trims accordingly.
Yeah, right. I mean, I think if you were driving your old Camaro, you'd just see black smoke out the back and go, it's time to push the choke in. So you essentially are your own oxygen sensor.
It's not that sophisticated. It is just a carbureted car. There's no sensors on it.
Well, that's the beauty about sensors. You know, they really do the work for us, and keeping them in very good condition is a priority for NGK, especially for servicing vehicles at the highest level. Are there any tips that you might have for, say, testing an O2 sensor that you're not 100% sure if it's spot on or it's giving you issues?
My number one tip would be to ensure that the sensor is in closed loop mode before you use a scan tool to check its operation and monitor its live operation. Because if the sensor hasn't reached the minimum operating temperature and is still in open loop mode, it could be misdiagnosed as not operating correctly.
Right, so you really need to get it up to speed, up to temperature.
Yeah.
Okay. Any other checks you can do?
Not off the top of my head.
I've seen a few people sort of pull them out, have a look at them, and make sure that they haven't been hit with anything or melted or dented and things like that. And that's the physical inspection, but that involves taking it out of the actual pipe itself.
Yeah.
So probably more so the diagnosis needs to be, it's got to be warmed up, the car's got to be ready to go, and then you run your scan tools, yeah?
That's right. And then the scan tool, we'll give you some feedback. We'll just point you in the right direction, whether there's been an issue, like whether it's the sensor element that's failed or it's the internal heater that has failed.
Yeah.
And really what it does is point you in the right direction. You then got to then remove the part and diagnose exactly what has happened.
Yeah.
And then based on what's that, then diagnose what or determine what the actual cause of it was. Because quite often a failed O2 sensor is a result of something else occurring further upstream. Like, for example, you could have like coolant entering the exhaust from a leaking head gasket, and that can cause thermal shock to the sensor, which can cause the element to crack. Or if you've driven through floodwaters, same thing. It causes the temperature to cool down rapidly.
Yeah.
And that can cause the ceramic to crack.
Yeah. And a lot of different, contributing factors. And going back to the physical side of things, you can check things like plugs, connections, leads, mounting brackets and stuff like that, making sure everything's 100% where it needs to be. So it's not hard to service these items, especially if you've got a vehicle coming in and it's running rough and you've done all the diagnostics down to the O2 sensors. You're really narrowing things down. And what happens if a car's got more than one? Because now we're seeing vehicles with multiple sensors in multiple parts of the exhaust system. What's the go? If one fails, do you have to replace them all? Does the ECU, adjust accordingly, or do they all have to go?
Yeah, so it's not necessary to replace them all. Say if a vehicle's fitted with one pre-cat or one post-cat sensor, then you only have to replace the failed sensor. But where there's sensors running in parallel, which what I mean by that is there's two pre-cats or two post-cats.
Yes.
We recommend replacing the pair if one's been diagnosed as requiring replacement. The reason behind this is during normal operation, the parallel sensors reference values are very similar, and these sensors usually age at the same rate. So when if you just replace one of them, there can be an imbalance between the signals from these sensors feeding back to the ECU.
Yeah, right.
Which can result in the...
You better be safe. Just get them both swapped out.
Yeah, that's right. Because if you don't, what can happen is because the ECU might still, be getting, referencing the old one, it might end up causing premature failure of the newly replaced sensor, or you might find the one that wasn't replaced will fail soon after.
Well, if we walk away from the OEM manufacturing side of things and head towards the aftermarket, and, we heard about the cars that you've got, and I've got a few aftermarket stuff as well. Let's talk about, say, maybe some of the conversions that people are doing this day and age. And let's take, for argument's sake, like an LS Gen 3 engine, and we're putting it into an early model Holden. What sort of aftermarket application does NGK do in regards to oxygen sensors for that sort of application?
So the sensor has to be linked to the ECU that it's communicating with.
Yes.
So if you're doing an LS conversion, which is really common,
yes,
and you're running the factory ECU out of the Commodore, then the listing is still the same. It's still run the same oxygen sensor that we list for that vehicle that the ECU came out of.
Yep. Yes.
If in terms of aftermarket, there isn't really anything as such. All that you need to make it to ensure is that when, like you say, you're running an aftermarket exhaust, that where it's positioned in the exhaust, the lead on the oxygen sensor is still long enough to be able to connect to the loom.
Of course.
Because we don't recommend cutting the plugs and extending the wires and all that.
Yeah.
Yeah.
You quite often see that, and you will have issues down the track. It might work initially, but down the track you're going to have some issues and so forth, and different rates and so forth. Let's also talk maybe about the upgrading and so forth. If you're looking at a vehicle that's come through, and in some of these workshops you'll have people who have powered up vehicles and bigger turbos and boost and all that sort of stuff. Do you have to adjust the O2 sensor? Do you have to up it in spec?
No, it's still the same part number. So it's unlike spark plugs where you need to adjust them all. It's still the same oxygen sensor. It's still trying to measure the same, stoichiometric point or close to.
Yes.
Which doesn't change regardless of the performance of the engine. You basically just stick with the original one. You might adjust or if you modify the engine, you will adjust the tune on it, but you still use the same O2 sensor.
Okay. And one of the things that's always, not confused me, but I've always wanted to ask someone the question, oxygen sensors, and I've got a bit of a hunch on the answer, but why are they always on the top or the side of the pipe, never on the bottom? It's
positioned there so that, part of combustion is you get condensation or water droplets in the exhaust.
Yeah.
And so the sensor's positioned in the exhaust so that, with the natural flow of the gases through the exhaust, you try and position it where just slightly out of it, so the water droplets go past rather than hitting the sensor.
Yeah, and pull in it.
Because if you have it in the path, you got these water droplets hitting a hot ceramic element. It can, rapid cooling can cause them to crack and.
Yeah. You've confirmed my notion. And if you have a head gasket let go and it decides to run coolant all the way through, then you're saving the O2 sensor by it running along the bottom. Another quick one as well. Obviously, vehicles run at different mixture rates and so forth, and you quite often have the oxygen sensor just in front of the catalytic converter. When you have the oxygen sensor behind the catalytic converter, is that like a secondary, or which is considered the primary?
So the primary one is the pre-cat one.
Yes.
That's the one that's measuring the how the air fuel ratio of the engine or what's coming out of the exhaust, and so we call that one the control one. The one that's post the cat or post cat, that's what we call the diagnostic sensor. So it's actually monitoring the performance of the cat and to see if the emissions are sort of outside the set parameters where it's becomes a pollutant. So that one's really there to monitor the car's emissions.
Yeah, right. Well,
and make sure that the whole system's still operating correctly.
We see a lot of cars now that are obviously stopping at the lights to save from an economy point of view and then firing back up. How is that affecting your techs on the O2 sensors, and they sort of getting that pre-start hit constantly as opposed to sort of just getting it once before the journey? They're getting it half a dozen times, 20 times. Does that affect the O2 sensor at all?
Yeah, no, not really. The only impact it might have is if the car's stopping, then it's allowing everything to cool down.
Yes.
But the cars are monitoring temperatures of everything, and if it just like it's monitoring the battery voltage, if that's getting too low, it would also be monitoring the temperature of the emission components, and if needed, it will fire the car up just to keep everything up at temperature. But other than that, stop start's not really having much effect on it.
James, I'll tell you what, you have given us a lesson on O2 sensors today. I've learned a hell of a lot just by listening to you in this short period of time. Thanks very much for coming in and chatting with us today on the show. There's certainly a lot to learn and a lot to be respected about O2 sensors, isn't there?
There is, and technology is only going to continue to improve.
It certainly is. Well, if our listeners have any follow-up questions about anything we've discussed, they can go ahead and reach out to NGK via the Mechanic.com.au community. And if you're not already a member of Mechanic.com.au, join the thousands of other mechanics around Australia who are earning more, learning more, networking more at Mechanic.com.au, the online home of Australia's mechanics, by creating a free account today. Well, look, thanks for tuning in to Mechanic.com.au podcast, Australia's #1 podcast for automotive and repair professionals. If you want to unlock a whole host of trade-only resources, including our private community, competitions, educational content, job opportunities, training, troubleshooting, and much, much more, go ahead and create a free account now at Mechanic.com.au. Thanks for listening. Keep the sparks firing on all cylinders, and we'll see you for the next podcast coming very soon.